Welcome to this presentation. Today we are going to look at cardinality of a set versus cardinality of its power set. And please, if you are new to this channel, please kindly subscribe and hit the notification button so that you are notified whenever a new video has been uploaded. Like and share. So we have on the left hand side the cardinality of a set, and then on the right hand side cardinality of the power set. By definition, cardinality of a set, say set A, denoted by magnitude of set A, is the total count of unity elements in that set. Or we can still define it as the number of elements in a set. Cardinality of a set tells us how many distinct items are in that set. That is to say, cardinality of set A equals to n, where n is the number of elements in the set. Then on the right hand side, the power set is a set of all possible subsets of that set, including the set itself and the empty set. If a set A has any elements, then its power set is denoted by power set of A has cardinality of cardinality equals to 2 power n, or cardinality equals to 2 power the magnitude or power the cardinality of set A, whereby the cardinality of set A is n. Let's have examples. Let's have example 1. Given that set A is having members 1, 2, and 3, find we have Roman number 1, the cardinality, which is abbreviated as the magnitude of set A. Roman number 2, we find the power set of set A. Roman number 3, we shall define the cardinality of the power set. Let's have our response. Roman number 1, the cardinality of set A is the same as the n, whereby if set A is having the members as 1, 2, and 3, then to get the value of n, we just need to count off. So this is the first element, the second one, and the third one. So here the cardinality of set A is 3. Roman number 2, we have to find the power set, which is equal to, so we are going to list the subsets of set A. So in there we are going to have 1 as a set or a subset, shall have 2, shall have 3, shall have 1, 2, shall have 1, 3, we shall have 2, 3, we shall have the set itself, which is set A, and lastly we shall have the empty set. So this is the power set of set A. Then we have Roman number 3. We are to determine the cardinality of the power set, which is given by 2 power n, or 2 power the cardinality of set A. But we said n is equal to the cardinality of set A, which was 3, implying that the cardinality of the power set equals to the 2 power 3. If we simplify this, it becomes 2 multiplied by 2 multiplied by 2. This is equal to 8, implying that the cardinality of the power set equals to 8. Now, from the power set we have, let's try to count off. We have 1, we have 2, we have 3, we have 4, 5, 6, 7, and lastly 8. So there are 8 entries or 8 members or 8 elements in this power set of set A. We can have example 2. If set B is having elements 0, 2, 3, and 4, then find the Roman number 1, the cardinality of set B. Roman number 2, the power set. Roman number 3, the cardinality of the power set, you can have our response. We begin with Roman number 1. The cardinality of set B is equal to the value of n, but from set B serving elements 0, 2, 3, and lastly 4. When we count off these members, we start this is the first one, the second, the third, and the fourth. There are 4 elements in set B. So therefore, that the cardinality of set B equals to 4. So this is the same as, it implies that the cardinality of set B is the same as the number of members or elements in set B, which is also equal to the 4. Then in Roman number 2, the power set of set B equals to, so we are going to list down all the subsets of set B. So take time and finish Roman number 2 and Roman number 3. And after that, drop the answers in the comment section. Thanks for watching.